Have you ever wondered how many grains of sand there are in the Sahara and how deep it reaches? How much time would it take for you to pile it up? Here are the answers to questions you never even asked. Sahara. The vast and mysterious desert that covers North Africa represents one of the most challenging and unusual ecosystems on Earth. With its area of over 9 million square kilometers, the Sahara is slightly smaller than the United States, making it the largest desert in the world. It is estimated that more than 2.5 million people currently live there. However, the Sahara is not just an endless sea of sand and desert dunes. It is a living historical book with stories of ancient civilizations, migrations, and extreme climate changes. Through this video, we will explore its past, its astonishing size, the changes that have occurred, and what we can expect in the future. The Sahara spans across 11 countries, specifically Algeria, Chad, Egypt, Libya, Mali, Mauritania, Niger, Western Sahara, Sudan, and parts of southern Morocco and Tunisia. To better illustrate the size of the Sahara, we made a comparison with the UK and Ireland. This is how they would look if they were located in the western part of Africa. Both countries combined would cover only 3.5% of the total area. The UK would fit almost 38 times within that area and Ireland 109 times. The distance from east to west is approximately 4,800 kilometers, which is the same distance as from capital city of Switzerland, Bern, all the way to the North Pole. For a better visualization, you can fit exactly 50,000 Big Ben towers within this length. In theory, for that distance, at a speed of 100 kilometers per hour, you would travel by car for 48 hours without stopping, which is, of course, unrealistic. If you drove 8 hours a day, it would take you 6 days to reach the other side. On foot, where the speed is significantly lower, 5 kilometers per hour, it would take 960 hours or 40 days of walking without stopping. With breaks, walking 8 hours a day, it would take you 120 days. The Sahara is so vast that it would fit between the Earth and the Moon only 80 times. It is estimated that this desert contains around 1.5 septillion grains of sand. Only about 25% of the desert contains sand, while the rest consists of sedimentary rocks called sandstones. The sand reaches depths between 21 and 43 meters. Imagine someone gives you the task to move all the sand with a shovel. To calculate the amount of sand and the time needed for such an endeavor, we need the following input parameters: the volume of the shovel, the average depth of the sand, and the sand's share in the desert. First, we calculate the area covered by sand, which is 2.3 million square kilometers, and the volume, which amounts to 73.6 trillion cubic meters. Finally, we get the astonishing number of 2.45 quadrillion shovels needed to move all the sand. According to the internet, it takes 2 hours to move 1 cubic meter of soft soil over a short distance. This means you would need 147.2 trillion hours. People on average work about 90,000 hours in their lifetime, meaning one person would need 1.6 billion lifetimes to finish the job. However, it's not logical for this job to be done by just one person. There are about 3.5 billion people capable of working in the world. If all those people worked on this task, it would take them 42,000 hours or 21 years, assuming an 8-hour workday, 250 days a year. Nevertheless, these numbers are only approximate and should not be considered accurate. These figures could be much higher as factors like weather conditions, each person's working capacity, work speed, and so on have not been considered. What would happen if we managed to pile up all that sand? How big would this Saharan super-dune be? To calculate the dimensions of the super-dune, we need the maximum angle between the ground and the slant of a cone under which dry sand can stand, and the total volume of sand, which we previously calculated. This angle is 34 degrees. From the pictures, we can see the relationship between the height and radius of the cone. When we enter these values into the volume formula, we get a cone radius of 47 kilometers and a height of 31.7 kilometers. For a visual comparison, the dune is shown alongside the highest peak on Earth, Mount Everest, which rises to a height of 8.85 kilometers. However, the Sahara hasn't always been so vast. It has been proven that throughout history it has undergone periodic changes. Early cartographers depicted North Africa in various ways, often full of rivers, lakes, and even forests. The earliest maps date back almost 500 years. The first such map was created by Sebastian Münster. In the heart of the Sahara, one can see a forest and several rivers. Just a few decades later, a similar story is depicted by Giacomo Gastaldi and Abraham Ortelius. Scientists have also determined the duration of these cycles, with changes occurring approximately every 20,000 years. One of the most significant scientists in this field was the Serbian geophysicist, astronomer, and civil engineer Milutin Milanković. He was born in 1879 in Slavonia, then part of the Kingdom of Croatia and Slavonia within the Austro-Hungarian Empire. He finished high school in Osijek and then moved to Austria, where he earned a PhD in civil engineering. Until 1909, he worked as an engineer, after which he moved to Belgrade to work as a university professor. In the meantime, he developed a theory about the periodic changes in the Earth's orbit and tilt. In his discovery, he noted how these cycles influence the onset of ice ages by changing the amount of solar radiation reaching the Earth. Today, many streets bear his name, as well as craters on the Moon and Mars, even an asteroid. His image is featured on diner banknotes. Since 1993, there has been a medal awarded to scientists for outstanding research in the field of long-term climate change and modeling. So far, 33 scientists have received this award. Thanks to Milanković, we have a better understanding of the impact of astronomical cycles on climate changes and, consequently, the changes occurring in the Sahara. There is also various evidence that Africa was once divided by a body of water called the trans-Saharan Seaway. This marine route is believed to have existed approximately 50 to 100 million years ago. It connected the Atlantic Ocean with the Tethys Sea, which once separated Europe and Africa. The theory of the existence of the trans-Saharan Seaway is based on a series of geological evidence, such as fossil remains of marine organisms, sedimentary layers, and geological relief. Some of the largest marine animals that ever existed lived there. It is estimated that it was 50 meters deep and covered 3,000 square kilometers of what is now the largest desert. After its disappearance, sediments filled with fossils remained, enabling scientists to reconstruct a picture of a region rich in diverse life. However, although there is evidence supporting the idea of the trans-Saharan Seaway, the details of its geographical configuration and duration are not completely resolved. This idea remains a subject of research and debate among geologists and paleontologists. The last ice age ended approximately 10,000 years ago, and we are currently living in a stable geological epoch called the Holocene. It marks a period of significant climatic changes as the Earth warmed and glaciers retreated, ultimately leading to the development of modern human civilizations. A logical question arises: is the desert expanding or shrinking? It's impossible to give a simple answer to this question. According to some scientists, the Sahara has not stopped expanding since 1920s, when the first recordings began. They claim that since the first measurement, the Sahara has expanded by as much as 10%. It is predicted that by the end of the century, it could occupy the entire northern part of Africa and even expand into Europe across the Mediterranean Sea. On the other hand, there are studies that claim the opposite. The Sahara and the more fertile regions of Africa are separated by the so-called Sahel boundary zone. This area has seen a significant increase in vegetation over the past 3 decades. Additionally, there has been an increase in rainfall. If these trends continue in the coming years, it is predicted that similar processes could occur in the Sahara Desert. However, the countries in the region are not leaving anything to chance. They began fighting the spread of drought and sand in 2007. The African Union developed a plan and united 22 African countries in the construction of the Great Green Wall. The goal is to halt desertification by 2030, restore 100 million hectares of degraded land, and turn it into fertile soil. This initiative aims to impact the lives of over 500 million people threatened by the expanding desert. It is estimated that by 2023, 18% of this project has been completed, with over 20 million hectares of land treated. Do you think that humans and technological advancements are strong enough to fight against the forces of nature and influence future events? Share your thoughts in the comments. If you like this kind of video, follow us and stay tuned for the next one, where we explore the dark depths of the Pacific Ocean.